So just to wrap up the compound angles, I'm going to have you guys talk me through one of each of the examples that we've done so far. So the first type of problem we did looked something like this. We're looking from this corner down to that corner. We're looking for this angle here, and they called that angle A. And this angle here we called angle R. And let's say we're given that this is 1.4 inches thick, 1.2 inches wide, and 2.4 inches long. And let's say I want to know AR, and I want to know that length as well. We'll call that L. We can find R right away because R is going to be what? We're looking at this triangle here, right angle right there. We know this side and we know this side. So that means we have opposite and adjacent, which is tangent. So it's going to be an inverse tangent. The opposite side is 1.2, adjacent side 2.4. So the inverse tangent, 26.57 degrees. So this is 26.57 degrees. The next easiest thing to find is going to be the length. That length is going to be the square root of what? Perfect. Each of the three dimensions squared added together. That's our three-dimensional Pythagorean theorem. So 2.4 squared plus 1.2 squared plus 1.4 squared. 3.027 it looks like. That'll be inches. And then to find A. We know this. A is going to be this triangle in this triangle. We know this side, just our thickness, and we now know the length. Which means what we have, here's angle A. We have the 1.4, 3.027. What sides do we have? Opposite and not adjacent. This one's the hypotenuse. The adjacent would have been this one down here. Opposite and hypotenuse make sine. So since we're looking for an angle, it's an inverse sine of opposite over hypotenuse. So second sine 1.4 divided by the previous answer. 27.55 degrees. So we have R and A and the length for that block. Look familiar?
Is that angle A what we usually call the tilt?
The tilt would be up here. So what we would normally call the tilt would be 90 minus that angle. A is going off the horizontal, our tilt goes off the vertical. Another example we had was if we were drilling. You'd used inverse cosine instead of inverse sine here. Then it would have been still the same numbers here, just would have been inverse cosine. Yeah. So when you're drilling like this, now again, we're only going to take a look at the box that goes center to center on the holes from where it goes in to where it comes out. So we're looking at that. Pretend that's a straight line. And now we are looking for T, which is our tilt up here, R, which is our rotation, and we are still looking for our length L. And let's say I give you dimensions Let's say that this is 1 inch thick, 1.2 inches here, and 0.4 inches here. R is going to be what? It's inverse tangent of 0.4 over 1.2. Good. Giving us 18.43 degrees. Next, we can find our L. That'll be the square root of 1 squared plus 1.2 squared. Perfect. There you go. So we've got 1 squared, which is just 1, plus 1.2 squared, plus 0.4 squared. 1.612. And then our triangle for T. T is up here. You know this is 1.0 and this is 1.612. Now since it is T up there that we're finding, we're going to use inverse cosine. Good. So 1.0 over 1.612. So second cosine 1 divided by 1.612 gives us 51.66 degrees. What do you think? Not so bad?
Always divide by the hypotenuse.
Always, the hypotenuse always goes on bottom if it's in there, yep. You might be given a situation where still drilling the holes, but this time what we're looking at is a front view where here's the hole here, and it makes an angle of, let's say, 44 degrees from that edge. And then an end view here where you're looking at it, and it makes an angle of, let's say, 12 degrees in that direction. And that's all we're given. In fact, hey, if that's all we're given, we can find the angles. Now, if we were given this depth, then we could actually find the length of the bore and everything if we were given the depth. So let's actually do that. Let me give you a depth here. Let me say we have a 0.9 inch thick piece of material. Normally, if we weren't given a depth and we were just asked to find the angles, we'd pick a number. We'd do 10 millimeters or something easy like that. I'm giving you a depth so that we can actually find a length of cut on this one. So, here, let me put in my 3D drawing up here. Pretend that looks acceptable. So we're still looking for R, T, and we can find L because I gave you the thickness. So we can find this dimension. Oops, that's not where I want it. We can find this dimension here, which is just this dimension here, which is just going to be tangent of 12 degrees equals, if I call that x, x over 0.9, right? Because the 0.9 would be right here. That's the adjacent side. X would be over here. That's the opposite side. Opposite over adjacent makes tangent. So to solve that, put this over 1. It's just tangent of 12 degrees times 0.9 divided by 1. So 0.9 times tangent of 12. 0.1913. So this is 0.1913. Of course, this we gave you is 0.9. Over here, we do the same thing, looking for y, which is just going to be that dimension there. tangent of 44 degrees equals y over the 0.9. Because again, y is right here, that's the opposite, 0.9 is there, that's the adjacent. Put in a 1, we cross multiply and divide, so it is 0.9 times the tangent of 44. 0.869. So now that we have those dimensions, how do we find r? Inverse tangent of 0.1913 over 0.869. So second tangent, 0.1913 divided by 0.869 gives us 12.41 degrees. Length. Square root of 0.9 squared plus 0.1913 squared plus 0.869 squared. Second square root, 0.9 squared plus 0.1913 squared plus 0.869 squared. Gives us 1.266. Now to find tilt here, there's t. We know this is 0.9, this is 1.266. So to find t, it is inverse cosine of, perfect, 0.9 over 1.266. Second cosine, 0.9 divided by 1.266. 44.69 degrees. Any questions? Okay, next one. Next type of problem we did was where we had that corner machined off. Like this. So again, all I'm going to focus on is this chunk here that's been cut out. And the way we're going to look at it, we look at the whole block. On this one, it doesn't really matter. So if I look at this front view, let's say I'm given that this is an 18-degree angle here. Looking at the right end view, maybe I'm told that's a 30-degree angle. And all I want to find is my angle of rotation. Remember, my angle of rotation, if I'm looking at this thing from the top, this is my angle of rotation. My angle of tilt, get some of this out of the way. Oops, not that. My angle of tilt actually comes from, if I bring it at a right angle off of this top piece here, look at it going straight down, my angle of tilt is that angle there in that little imaginary triangle. That kind of fills out the rest of my corner, if the corner were still there. So that angle of tilt's a little trickier to find, but let's find our angle of rotation first. To find r, I need to know these dimensions, this dimension, which would be the same as the dimension here, and this one, which would be the same as the dimension here. Here I gave you no thickness. Since I gave you no thickness, we can guess whatever we want to. We'll call it 10 millimeters. Make it easy on ourselves. So if I call this x and y, x is going to be found by using tangent of 30 degrees equals x over 10 millimeters. Put this over 1 and cross multiply. 10 times tangent of 30 is 5.774. So it's this right here, 5.774 millimeters, not inches. Over here, to find y, tangent of 18 degrees equals y over 10. So put this over 1, cross multiply and divide. It's 10 times tangent of 18. Gives us 3.249. Millimeters. So that means R is the inverse tangent of 5.774 over 3.249. $60.63 degrees. Now remember, here is where we take this and we cut it here, and we now have a new triangle. And I need to know this length of this piece here. To find that length, that is the opposite side. I know the hypotenuse here, because this now becomes the hypotenuse of that new triangle. So opposite and hypotenuse is sine, so I know that the sine of 60.63 degrees is equal to that piece, if we call that z, over my hypotenuse of 3.249. So, put this over 1, cross multiply and divide. So it's 3.249 times the sine of that 60.6337. 2.83 I get, 2.832. Now that's 2.832. Now I'm looking at this triangle here. That 2.832 is that top side. It's 2.832. This was the 10 millimeters that I chose as my depth. Here's my tilt that I'm looking for. Tilt is the inverse tangent of 10 over 2.832. Giving us 74.19 degrees. Look familiar? Good.
What was the answer? I didn't see it.
74.19 is the tilt. The next one. Look like this. And we're concentrating on this edge right here, the intersection of the two surfaces. We wanted to find the angle and the angle of rotation and tilt. Remember, rotation and tilt, if we look at this, if we make this a triangle like that, R is here. And we're calling this the tilt. On the packet, actually calls it C. Technically, the tilt is this angle up here. But we're going to find that angle down there. Two ways I can give this to you. I can either give you dimensions or I can give you angles. For this one, I think I'm going to give you angles. So let's say I give you that this angle here is 28 degrees, and this one is 36 degrees. And I want to find those two angles. Well, what I'm going to do is I'm going to choose my depth here. Again, that only goes here to the bottom of the bevel to be 10 millimeters. So what I'm going to be able to get from that is this and this dimension. This one here, tangent of 28 degrees is going to equal 10 over, I'll call this y and this x, 10 over y. Put this over 1, so it'll be 1 times 10 divided by tangent of 28. Which is 18.81. Same is going to happen for x over here. Tangent of 36 degrees equals 10 over x. So I put this over 1, it's 1 times 10 divided by tangent of 36. $13.76. Yes.
Isn't really, I don't know, just like don't address this. Does 10 go over y or y go over 10? Does it?
It's always opposite over adjacent. See now, in this one we did up here, let's see, where was it? Here, this was the opposite.
Okay.
That's not the one I was looking for. Here, this was the opposite side, so x went over my depth. On this one, the angle is here, so now the opposite side is the depth, so it's the depth over x or depth over y. Okay? So,
When the 10 is on top like that, you always divide.
yes, pretty
If
much.
it's on the bottom, you always multiply.
Yeah, see, it's always cross, multiply, and divide. So here you end up dividing by the tangent. If it was down here, it's going to be that times the tangent. Yep. So now that we have these two angles, our angle of rotation, the 13.76, of course, goes back here, and the 18.81 is this dimension here. So the rotation is the inverse tangent of 13.76 over 18.81. So second tangent, 13.76 divided by 18.81, 36.19 degrees. Now to find the tilt, I need to know a length. Remember, this isn't the actual length because I guessed the depth. We weren't given the depth. But this is just a working length. It'll be 10 squared, 13.76 squared, 18.81 squared. Gives us 25.36 millimeters. So then the tilt, since T is on the bottom edge here now, this was the 10, this is 25.36. So we're using an inverse sign now because the T is down here, so it's the opposite side. So 10 over 25.36. So second sine of 10 divided by that previous answer, 23.22 degrees. So there we go. On the test tomorrow, there will be questions similar to the ones I just did. I will tell you that I did make a calculation mistake on one of the problems I did here. So don't blindly write down the answers I did here on the test. Hoping somebody would catch it, but they didn't.